Okay, geometry. This is 9-2. Getting more into circles and parts of circles. They're going to start talking about angles involved within circles. So our first kind of thing that they introduce is a central angle. And so what they're going to have is when you're given a circle and you're given like two radius lengths, you can kind of see this is like a little slice of pie right here. It's a kind of a large slice of pie actually. But the central angle will be this guy down here. Um, it's basically the angle made by those two radius lengths. And that angle will have a label of how many degrees that it is. So if I look at this, just this little slice of pie, that looks like it's more than 90 degrees. Maybe it's 110 degrees. So that's what the central angle would be. Okay. Now they're also going to talk about arcs. And an arc is just this like crust on the pie. That's what an arc is the pie crust. Okay, and pie crust will have measurements also. So this guy, the pie crust or the arc, will have a length measurement, and then it will also have like a degree measurement. Okay, so he kind of has two different measurements that it goes off of. This arc right here, his degree measurement will be the same as what the central angle measurement is. So if this angle is 110, then his degree measurement would be 110. But that doesn't necessarily mean that the length of this pie crust is going to be 110 feet or whatever. Maybe it's 15 inches is how long it is from here to here. Okay. So the arcs are going to have two different measurements, one in length and one in the degree measure that he is in. Okay, and so we'll kind of deal with both of those. Okay, now they're going to introduce some stuff to you when they talk about the central angles, like this central angle, angle 1 here. Even though it's a really big angle, he is still a central angle. Angle 3 and angle 2, all of those, if I were to add those together, that would add up to be 360 degrees because a full circle, like we did in trig in the last section, a full circle will end up being 360 degrees, okay? So given that, they're going to give some information to you, and we have three central angles here. We have this angle right here, excuse me, is 130. This angle right here, they put a little box in here, and that means 90 degrees, of course. Okay, and then they want you to figure out what x is, okay? So x is going to be the additional amount so that all three of them add up to be 360, okay? So basically 130 and 90, if I add those two together, try to do that maybe in your head, 9 plus 13 is 22, so 220 degrees is what that would be, okay? And I'm going to subtract that 220 from 360, and that will give me what angle x should be, okay? 360 minus 220, do some of that in your head. 36 minus 22 is 14. So I have 140 degrees is what my angle x is, okay? That's way faster than getting my clunky old calculator out. Try to do as much in your head as you can. So angle x is going to be, it's an obtuse angle, right? It's going to be more than 100 or more than 90 degrees, okay? But it's not quite a straight line, what 180 would be. It's 140 degrees is what that is. So kind of also check to see if it looks reasonable. 140 is going to be greater than a 90-degree angle, okay? So now they're going to introduce arc, and I already kind of did that up here, where we're talking about, like if this is the angle that I'm looking at, the arc that would correspond to that would be this guy. So this is a pie crust, but then the arc isn't only just the smaller side, this is technically an arc as well, okay? And he has to deal with the central angle of this guy. Okay, now this green central angle will be more than 180 degrees because he's more than half of the circle, right? 180 degrees is just, like when we did our right triangle trig and stuff, 180 degrees is just from here to here. It's that straight line. Well, this is more than just a straight line, right? So it's going to be more than 180 degrees. And his arc will also be more than 180 degrees as well. But there are two arcs that make up this circle, okay, because of how he's sectioned off, okay? Now you will have three different types of arcs. You'll have a minor arc, you'll have a major arc, and you'll have a semicircle. And that's just based on how many degrees it is, okay? So a minor arc is going to be less than half of the circle, which will be less than 180 degrees. 180 degrees is exactly half, okay? So this guy is going to be a minor arc. He is less than half of the circle. half of the circle, if I would connect this all the way over, would be that guy. So it would be from here all the way around. But AB is not quite all the way, not quite half. So he is going to be a minor arc. Now, using that same circle, they have then, instead of saying AB here, they've said this guy right here, okay, going around this direction. This is going to be a major arc because it is more than half of the circle, okay? And then this guy is going to be a semicircle, okay? Now, sometimes they will label these just a bit differently. Like up here, they said that this was arc AB right here. Well, technically, this is arc AB as well, right? So it's like, how do I know if I'm looking at the small arc AB or the large arc AB? So what they'll do is they'll drop a point down here, and they called it D. So they'll call it ADB, ADB, and that's how you know that you're going the long way around the circle rather than the short way around the circle. So they've added that extra point in there so that you know that for sure. Same thing here with the semicircle. How do I know that it's that top side semicircle versus the bottom side semicircle? Well, they've said ADB, which is this length here, okay? So just kind of take note of that. This one is going to be greater than half of the circle, or greater than 180 degrees, and this one's equal to half or equal to 180 degrees is what a semicircle will be. So that's what those guys look like, okay? All right, so they're going to have us go down here and just look at some things and measure some things. So they want us to identify whether it is a major arc, a minor arc, or a semicircle, and then find its measure. So they want to know GH, okay, arc GH. Okay, notice how they have this labeled. They say the measurement of GH, and they have this little arc symbol over top of it. That's how I know that I'm doing this thing here. I'm looking for that length, okay? And that length is going to be 122 degrees, just like the central angle is. So he's 122 degrees, and he is going to be a minor arc because it's less than 180. So minor arc, okay? That's what he is. Okay, B is GLH, okay? So GLH, GH was just from here to here. So they put that additional letter in the middle there to know that I'm going this direction. I'm going from G to L and then around to H, okay? They could have also done GJH as well, right? So I would know that they're going this way around, but I'm going this direction, okay? So they want to know, first of all, how many degrees is that from here all the way around, okay? Well, GLH is going to be everything except that 122 degrees, right? Okay, so if 360 is the whole way, I would take 360 and subtract 122, and that would give me, I don't know, 138 maybe? No, 238. Let me check. 360 minus 122, 238 degrees, okay? And since 238 degrees is more than half of the circle, that's going to be a major arc. So a major arc there, okay? And you can see that it's more than half of the circle. And then the last one is GLJ, GLJ, so this bottom side just from here to here. So just this bottom edge, okay? And that is entirely half of the circle. We're looking at like this arc, or this central angle, this arc here. That is going to be 180 degrees, so it is a semicircle. Okay, so we have an example of each one of those, what those kind of look like. Okay, let's go to the back side. Now, they're going to try to confuse you a little bit, but don't let them do this. This is a pie graph, okay, and they're labeling things in percentages rather than labeling them in degrees, okay? So this is 18%, 18%, 20%, 14, 14, and 16%. If I would add all of those up, those should be equal to 100%, okay? But degrees is based upon 360 degrees. Okay, so I have to do a little bit of conversion there because percent is not going to be the same thing as degrees, okay? So they want to, first of all, start with CD, and CD is this little arc right here, and they're saying this central angle right here out of this little slice of pie is 18%. Well, that's 18% out of 100, but I want 18% out of 360 degrees. So how many degrees will that be? Well, 18% as a decimal is just going to be 0.18, and I'm just going to take that times 360, and that will tell me how many degrees it is. Yeah, how many degrees it is. So 0.18 times 360, and that's 64.8 degrees. Ooh, 64.8. There's not a decimal there. 64.8 degrees. Okay, so it's a lot bigger than 18 degrees, right? It's not just 18 degrees, it's 18%. So it's 64 degrees. Okay, now I also kind of try to think of this as you know, how reasonable this answer is. If I'm looking at 25%, 25% is a fourth of a circle. How many degrees would 25% of a circle be? Okay, if a whole circle is 360 degrees, and we kind of know from trig in the last chapter, from here to here is actually 90 degrees. Okay, so 25% is going to correspond to 90 degrees. Okay, 50% or half would be 180 degrees all the way around here. Okay, but we're looking at 18%, which is less than 25%. So my answer should be obviously less than 90 degrees. So just kind of do a rough check there just to make sure. They also, I have a typo here, I don't know why C showed up, but they want to also check to see what is the measurement of arc BC. BC is this guy right here. Okay, so basically I'm looking at this slice of pie now. Okay, and they want to know what the length of this arc is in degrees. Okay, well that one's also labeled as 18%. So shouldn't it be the same as what this one is? And that's what this theorem up here says, is that if you have two arcs that have the same central angle, or the same measurement here, like 18%, 18%, they will both have the same degrees. Okay, so I don't have to do that conversion again. I can just say that that's going to be 64.8 degrees as well. Okay. All right, moving on. Use arc addition to find the measurements of arcs, okay? So the things that they have labeled here is that this is going to be 63 degrees, okay? This little arc right here, or that central angle there. They also label this with a box, which means that this one is 90 degrees, okay? So I know kind of like this little chunk right here, these two chunks together are 63 and 90, okay? They want me to find AED, which is this, the length from here to here. How many degrees will that encompass? Okay, that's 63 and 90 together, which would be 153 if I add those two together. I'll write that down. 63 plus 90 is going to be 153 degrees. So it's just kind of showing you that you can add those arcs together and that will give you the entire length. Now, they want to know what ABD is. Okay, so on the opposite side, ABD is going to be this length. Okay, well that's the other half, or the other, basically the rest of the circle besides this 63 and 90. Okay, so how would we find from here to here if we know this part? Okay, I know that this chunk right here is 153, and I know that the whole thing is 360, so I'm just going to subtract 153 from that. Okay, and that's going to give me like 207, I think. 207 degrees. Let's check that. 360 minus 153 is 207 degrees. Yeah. Okay. All right. Last one is arc length. Okay. So we've talked about arcs and degrees, and I said arcs have two measurements. One of them is degrees, which we've been talking about already. And now we're going to start to talk about the length of this from here to here, okay? So that's getting into the length in inches or in feet or in miles or in whatever we're talking about, not in degrees, okay? They want us to find the length of arc ZY. I know that that arc is 75 degrees because the central angle is 75 degrees. And then the other thing that I know is that the radius is 4, okay? So what I'm going to do is I always set these up as a proportion, and then it helps me to figure out kind of how this thing works here. Okay, and I'm going to set it up as like a 3-part proportion. So I'm going to do the part over the whole. Okay, so that's what I'm going to do. I'm going to do the part over the whole, and part over whole, and part over whole. Okay, so what I'm doing is the whole circle would be 360 degrees. but the part that I'm looking at is only 75 degrees. I'm only looking at 75 degrees of it, okay? So this is going to be my degree column, okay? And then this column, I'm going to actually convert that to length. L-E-N-G, I can't spell, length. I'm going to convert that to the length here, okay? Now the length of the part, this length right here is what I don't know. I'm going to call that X. But I can figure out what the length of the whole thing is. That would be the length all the way around. Okay, well, what's another name for the length of the whole way around? That's going to be the circumference. Okay, so the whole way around would be the circumference, which is diameter times pi. Okay, well, if the radius is 4, the diameter is going to be 8. So I have 8 times pi, and I'm just going to go ahead and leave 8 pi in there. Okay, rather than putting it out as a decimal right now. Okay, and then I have this proportion that I can go ahead and cross multiply. So I can cross multiply that, okay? So I'm going to take 75 times 8 pi. 75 times 8 pi, and it's going to give me a decimal. So I have 1884.96 equals 360x, okay? That's what the other part of it would be. And then to get x by itself, I'm going to divide by 360. Divide by 360. So taking that number, still in my calculator, dividing by 360, and I get 5.24. So over here, this length right here, from here to here, this length is 5.24 inches. Okay, and that's how I kind of do my length. So I do the degrees here, the part over the whole that I'm looking at, the part over the whole for the length. The whole then is represented by the circumference. Okay, so let's do another one over here. They want us to find, still zy. So this length here, which is 130 degrees, I know that, but I need to figure out what that is as a length rather than a degree measurement. Okay, so again, I'm going to do the part over the whole, and then I'm going to set up my proportions. So part over whole. Okay, I put my degrees here. So the degree part that I want is 130 degrees out of a total of 360, which would be the whole circle. And then I don't know the length of that part, but I do know the whole length would be the circumference. Okay, so circumference is diameter times pi, and in this case, 10 is giving me the diameter. Okay, so this would be 10 times pi, and that's going to be the whole length. Okay, so now I just cross multiply. Okay, so I have 130 times 10 pi. Let's start with that. 130 times 10 pi, and that gives me, 4084.07. Okay, that's equal to, the other side would be 360 pi, or 360x, and then I divide by 360. Okay, so x is going to be, divide by 360, and I get, last, 11.34. That's what this length is right here, 11.34 centimeters. Okay, so there's other ways of doing this, but the easiest way for me to just explain it to you guys is just to set it up as a proportion. So that's how I'm going to have you guys do it for now. Okay.